Hello and welcome back. This is presentation 7-8. The topic is inferences regarding proportions, and we're going to look at sample sizes. This material is in your workbook, pages 7, and your textbook, chapter 7. Now, in light of the recent election, we're going to look at a hypothetical situation. A random sample, 588 people in central Alberta, 321 indicated that he or she would vote Conservative if an election were held today. Find a 95% confidence interval estimate of for the population of all potential voters in the region. Well, in this case, a point estimate of the parameter is called p hat, which is your x, your number of people in favor, 321, or 588, and that's 54.6%. Now, in the distribution of proportions, we have the standard error that you see on the screen here. And in this case, since we don't know what the true proportion is, we're going to use p hat, which is the number at the top here. Substituting it in, we have the standard error, 0.0205, and we know now that that is effectively the 68% confidence interval above the mean, above the proportion, where the sample proportions will fall within one standard error. Now, the margin of error is the 95% interval corresponding to z equal to plus minus 1.96, and 1.96 times your standard error gives you the confidence interval. So we have our estimate, 54.6%, plus or minus your margin of error, and that's this area across here. And we see here effectively, if we do come up with a p hat of 54.6, effectively we're saying it's at the outer edge here, and if we come up with that confidence interval, there's 95% chance this interval will capture the true population proportion. Now we're saying, on the basis of what we have here, determine how large the sample size is required to find an estimate of p to within plus or minus 0.02. And look at the screen here. For 99%, the z-score is 2.575, and we're looking for that margin of error to drop from 0.04 to 0.02. In other words, cut in half almost. And we're going to use this margin of error formula here. For 99%, the z is 2.575. We want that to be plus or minus 0.02. If we square both sides and cross multiply, we have this expression. Solving that, n is equal to 4110. So in order to find an estimate of the population proportion p with 99% reliability, we must choose a sample size of 4110. In the general case, if you look at this formula here, this becomes what you see here on the screen. Now we're going to look at what happens if p is unknown. And from the previous screen, you saw this expression here. And following this over, you see, if we don't know what p hat is, say we don't know p nor p hat, then we're suggesting that this expression here on the left, the squared expression, is just a constant. And we're wondering what constraint there is on these p hats, and effectively we look at this as a quadratic in p. This is an inverted parabola, as we'll see here. Here it is here. And as you can see that for individual values of p hat, we substitute in here the expression, and we see the sample size down this right column here. And if the point is here that we don't know what p hat is, then we choose a large p as possible, or choose p so the n is as large as possible, and that's this middle of that parabola, and that corresponds to n equal to 4100. So the maximum value is 4145, occurs when p is equal to a half, and if you look on the left here, we put these in for a half, and we have this expression here. A half times a half is a quarter. So when no value of p hat is known, and you need a sample size n for a given level of confidence 99% with a margin of error 0.02, we have n to be as maximum as possible, and that's 4145. Generally, when p is unknown, we have this expression here, and you can use that in your formulations. Well, that's the end of 7-8. Please review it as required and go to lesson 9.